In this video, let's see another IIT JEE problem which was based on the topic of system of equations of the chapter Determinants, was asked in the year 1978 for 2 marks. The question says consider or given these 3 equations. You see here 3 equations are given where ABC are what? These are the constants of the variables, right? Are not all 0. Not all 0 means you have a short trick, you have to put the coefficient matrix determinant equal to 0 and have to prove that a square plus b square plus c square plus 2ab equal to 1. Now I have already told you in my previous videos on IIT JEE questions that for not all 0 coefficients or for non-trivial solution, you have to always put the det value or the determinant value of the coefficient matrix equal to 0, right? So what is the coefficient matrix or the determinant? Let's write it. It has to be there from these 3 equations. But you see, these equations are not rearranged properly. You see that I have x on one side, yz on the other, which shouldn't be the case. So let's rearrange and then make these equations suitable for us to write the determinant. X is here, fine. So x coefficient should be 1. Cy should be the other side. So it goes to the other side, it is minus cy. So the coefficient of y is minus c. Bz goes to the other side, becomes minus b, the coefficient of z. Next is what? Cx is here, fine, make the coefficient as c. Y is to the other side, bring it to one side, it becomes minus y, so coefficient is minus 1. Next is az, so a is my coefficient for z, which is on the same side as x, so no issues or no problems with it. Next we have z is equal to bx plus ay, bx means the coefficient of x, y has the coefficient as plus a. Next is z to the other side going, it is minus 1, the coefficient. And you know everything has to be put equal to 0 in the case of coefficients not all 0, right? Now let's start expanding and evaluating this determinant, ignoring the first column, ignoring the first row. You have minus 1, a minus 1. Next is moving to minus c. Minus c becomes plus c since it is positioned that ways, and here we have ignoring this, it is cab minus 1. Ignoring the second column and the first row, right? Minus b here. Inside is what? You have to ignore the third column, the first row. You have c minus 1 ba. C minus 1 ba. Everything equal to 0. That means expanding should be there in such a way now that you have to simply cross multiply these. Cross multiplying, minus into minus is plus 1. A into a is minus a square. To the other side plus c. C into minus 1 is minus c minus ab. You know bottom to up is a negative sign. Minus b, c into a is ca plus b equal to 0. Now you have to expand, that means you have to simplify 1 minus a square minus c square. Here is the multiplication. ab into c is minus abc. ab into c is minus abc. b into b is b square equal to 0. Things to one side, okay, things to other side, place them. 1 is here, let it be here. Everything is in minus, move to the other side, it becomes plus. A square is here, b square is here. So a square plus b square, let me cancel or circle these that yes, we have placed them in the proper position. 1 is already here. C square goes to the other side plus c square. ABC here is minus 2abc, goes to the other side, becomes plus 2abc. So this was what we needed to prove. We needed to prove that a square plus b square plus c square plus 2abc is equal to 1. And we have placed all of them. Let's circle them all. And this question is hence complete.